Let's start with the 80th example, and it is said that prism 1 with a bar of mass 2 placed on it gets a horizontal acceleration w towards left. So here the prism 1 is moved with acceleration say w, or we can say a, towards left, which is given to us. At what maximum value of this acceleration, will the bar remain stationary? So now if I take the FBD, if I take this bar here like this. So here if this is the bar, and if I take the FBD of this bar as 1 with respect to 1, so the component of the weight of the bar which can be resolved directly along the plane and perpendicular to the plane is mg cos alpha, mg sin alpha. The pseudo force ma will act towards right. The reaction from the surface will be in the upward direction, and we want a as maximum acceleration. Okay, so that's why the friction is not helping the acceleration to prevent it from sliding. Okay, so I will take friction in the downward direction, because now there will be two possible direction of friction, either upward or downward. It depends what kind of acceleration is asked. Here the acceleration is maximum. If it is minimum acceleration, then the friction will help acceleration in preventing the block to slide, and we will get a as minimum. But here a maximum, we want acceleration maximum, that's why friction must be taken in the downward direction. Keep this in mind. Now I just have to resolve ma. So I just have to resolve ma. So if this is alpha, then corresponding angle, this is also alpha. So I will resolve it into two parts. So it will be ma cos alpha, and this will be ma sin alpha. As the block to be in equilibrium, so the value of n must be ma sin alpha plus mg cos alpha. And in order to prevent the block from sliding, friction plus mg sin alpha must be balanced by alone ma cos alpha. As you can see, ma cos alpha alone should balance these two forces to prevent the block from sliding either upward or downward. Here the friction, maximum value of friction will be k into n plus mg sin alpha plus ma cos alpha. The value of n, I can substitute the value of n from the very first equation here. So it will be k in bracket ma sin alpha plus mg cos alpha plus here. Now from here this mg sin alpha remain as it is equal to ma cos alpha as it is. I will multiply this k inside, so it will be k ma sin alpha plus kmg cos alpha plus mg sin alpha is equal to ma cos alpha. Now I will rearrange this. So we need to find a, so this a terms must be taken together. So I will send this on this side and take mg as common. So if I take mg as common, it will be k cos alpha plus sin alpha is equal to ma as common, cos alpha plus k sin alpha. So this m and this m will get cancelled out. So the acceleration would be k cos alpha plus sin alpha. Now when this particular term will come here, it should become minus. By mistake I have written here plus, so this should be minus. Okay, divided by cos alpha minus k sin alpha. So I can take cos alpha as common, so it will be k plus tan alpha upon cos alpha as common, so it will be 1 minus k tan alpha. This will get cancelled, a is equal to, so it will be k plus tan alpha upon 1 minus k tan alpha. Okay, or from this step it is this. And if I take sin alpha as common from this step, so if I take sin alpha as common, so it will be k cot alpha plus 1 sine alpha as common, okay, I am telling you, okay, if we take from here cos sine instead of cos alpha, if I take sine alpha as common, then what would be the solution? So sine alpha as common, so it will be cot alpha minus k. This will get cancelled and the answer comes out to be 1 plus k cot alpha upon cot alpha minus k. Okay, and that's either this is the answer or this should be the answer to this question. Here this is I, if we take sine alpha as common, then this will be the solution, and if I take cos alpha as common, then this will be the solution. So there will be two possible answers in terms of tan and cot, whatever in the option, then accordingly you have to simplify and reduce it. Thank you.